Good morning, everyone. I'm delighted to welcome you all today. Today, we will be discussing an important aspect of microbiological safety, decontamination and disposal of microbiological media and cultures after use. My name is Dr. S.K. Singh, and I hold a PhD in this field. Over the course of this presentation, we'll explore the best practices for safely handling and disposing of used media and cultures, ensuring safety and compliance. Let's get started. Let's talk about the importance of proper disposal of microbiological media and cultures. Once these materials are used, they become biohazardous, meaning they can pose health risks if not handled correctly. Improper disposal can lead to several serious issues. For example, cross-contamination can occur, potentially spreading harmful microorganisms to other surfaces or materials. Environmental pollution is another concern, as pathogens could contaminate water or soil if not properly contained. And of course, there's the risk of occupational exposure, putting lab workers and others at risk of infection. That's why regulatory agencies require that all biohazardous waste be validated and properly decontaminated before disposal. This step is crucial to protect public health, the environment, and everyone involved in the process. So, adhering to these guidelines is not just about compliance. It's about safety and responsibility. Let's talk about the scope and applicability of this procedure. It applies to a variety of media and samples that we commonly work with. Specifically, it's relevant when using solid and liquid culture media, which are fundamental for growing and studying microbes. It also covers environmental monitoring plates, which help us keep track of contamination in our environments. When it comes to microbial cultures, this procedure is applicable to bacteria, fungi, and yeast, pretty much any microbial organism we might be working with. This includes inoculated broth, slants, and stock cultures, so it's quite broad in its application. However, it's important to note what it doesn't apply to. Non-inoculated sterile media, for example, are handled separately and are not within this scope. So, this procedure is focused on samples or cultures that have already been inoculated or are actively growing. Understanding these boundaries helps us ensure we're applying the right procedures to the right materials, maintaining accuracy and safety across our work. Let's take a closer look at the risk classification of microbiological waste. First, we have the low-risk category. These are environmental isolates or non-pathogenic strains, meaning they don't pose a significant threat to health. Moving on, the moderate risk group includes indicator organisms like E. coli and S. aureus. These are organisms that can signal potential contamination or presence of more dangerous microbes, so they require more careful handling. Finally, the high-risk category covers pathogenic or spore-forming organisms. These are the most dangerous because they can cause infections or survive harsh conditions, making their disposal critical. The key point here is that the disposal method we choose depends directly on the risk level. Low-risk waste can be treated more simply, while high-risk waste demands more stringent procedures to ensure safety. This classification helps us manage microbiological waste responsibly and protect both public health and the environment. It's all about matching the disposal method to the level of risk involved. Let's talk about the principles of decontamination. The main goal here is to reduce the microbial load to a level that is safe and non-infectious. Essentially, we want to make sure that any potentially harmful microorganisms are brought down to a point where they can no longer cause infection. Another critical goal is to prevent aerosol generation, which is important because aerosols can spread infectious agents through the air. By controlling this, we help protect both personnel working in the environment and the surrounding environment itself. Now, when it comes to the common methods of decontamination, we typically think of autoclaving, which uses pressurized steam to sterilize equipment thoroughly. Chemical disinfection is also widely used, involving disinfectants that kill or inactivate microbes on surfaces. Thermal treatment, on the other hand, employs heat, whether dry or moist, to decontaminate items effectively. All these methods are connected by the core principles we just discussed. They're designed to ensure safety, prevent infection spread, and protect everyone involved. Understanding these principles helps us choose the right method for each situation, maintaining a safe and effective environment. This sterilization method is suitable for a variety of materials, including culture plates, broths, slants, pipette tips, and other disposables. It's primarily done through autoclaving, which is considered the most preferred and validated method for ensuring complete sterilization. When autoclaving, the typical parameters we use are a temperature of 121 degrees Celsius, give or take a couple of degrees, maintained for about 15 to 30 minutes. Additionally, we apply a pressure of 15 psi to achieve effective sterilization. These conditions are carefully chosen because they reliably eliminate all microbes, making sure our materials are safe for further use. This method plays a crucial role in our overall sterilization strategy, ensuring safety and compliance in our laboratory practices. Now, let's talk about autoclave validation and monitoring. When we're validating our sterilization process, a key component is using biological indicators, specifically Geobacillus stereothermophilus. This microorganism is highly resistant, so if it's inactivated, we can be confident our sterilization is effective. In addition to biological indicators, we also use chemical indicators, like class I through V strips. These provide a visual confirmation that the sterilization cycle has been completed. However, they are not sufficient alone. That's why load pattern qualification is necessary to ensure our specific load types are being properly sterilized. Routine monitoring is essential, too. We need to regularly check parameters like time, temperature, and pressure during each cycle. Consistent monitoring helps us maintain the integrity of the sterilization process. And finally, the key acceptance criterion is complete inactivation of microorganisms. If our biological indicators show that all microorganisms have been destroyed, then we can confidently say our sterilization process is successful. This ensures patient safety and compliance with quality standards. Now, let's talk about chemical decontamination. This method is used in situations where autoclaving isn't feasible or when it's required as a pretreatment step before sterilization. It's an essential part of ensuring proper disinfection, especially when other methods can't be applied. Some common disinfectants we rely on include a 1 to 2% sodium hypochlorite solution, which is essentially a diluted bleach, a 2% glutaraldehyde, and a 5% phenol solution. These agents are effective at reducing microbial contamination when used correctly. It's important to note the contact time needed for these disinfectants to be effective. Usually, a period of 30 to 60 minutes is recommended, and this has been validated through research. Ensuring adequate contact time is crucial for the disinfectants to work properly and to guarantee safety. So, in summary, chemical decontamination is a vital alternative when autoclaving isn't an option, and choosing the right disinfectant, along with proper contact time, ensures effective decontamination and safety in our practices. Now, let's talk about the proper disposal of solid media like plates and slants. First, these items should be collected carefully in biohazard bags to prevent any risk of contamination. Once collected, they need to be autoclaved using a validated cycle to ensure all microbial life is destroyed. After autoclaving, if necessary, the media can be shredded or mutilated to further ensure safety before disposal. Finally, the waste should be disposed of according to the biomedical waste category it falls into, following local regulations. It's important to remember that color coding helps us identify the correct disposal method, yellow or red bags, depending on local rules, so always be mindful of these color codes. Overall, proper disposal not only keeps us safe, but also supports responsible waste management in our lab. When it comes to disposing of liquid media and cultures, there are a few key steps to follow to ensure safety and compliance. First, you want to add a disinfectant, such as a 1% hypochlorite solution, to the waste. It's crucial to maintain the validated contact time, meaning you need to leave the disinfectant in contact with the media for the appropriate period to effectively neutralize any biological material. If necessary, neutralize the disinfectant afterward to prevent any potential interference with the disposal system. Next, drain the treated waste through your effluent system, making sure it flows properly and safely. Remember, always follow the guidelines provided by your effluent treatment plant or sewage treatment plant. These are designed to ensure that disposal meets environmental and safety standards. Overall, proper disposal of liquid media and cultures isn't just about following procedures. It's about protecting both people and the environment. So, adhering to these steps helps us maintain a safe, compliant, and responsible lab environment. When dealing with spillage or accidental exposure, the first step is to immediately isolate the area. This helps prevent the spread of contamination to other parts of the workspace. Next, cover the spill with an absorbent material, such as paper towels or a spill kit, to soak up the liquid safely. After that, it's important to apply a suitable disinfectant to thoroughly sanitize the affected area. Remember, the disinfectant needs to stay in contact with the surface for at least 30 minutes to be effective. Lastly, documenting the incident is mandatory, along with reporting it properly. This ensures proper follow-up and helps maintain a safe environment for everyone. Handling spills carefully and methodically is all about minimizing risk and ensuring safety at every step. Let's talk about personnel safety and PPE, which are absolutely essential in our lab environment. First, when it comes to mandatory PPE, there are a few key items you must always wear. A lab coat or gown is critical to protect your clothing and skin from potential spills or splashes. Gloves are also a must whenever you're handling hazardous materials. They act as a barrier to prevent contamination. Masks or face shields are important as well, especially when working with aerosols or infectious agents, to protect your respiratory system and face. And of course, closed footwear is essential to protect your feet from any accidental spills or dropped objects. Now, beyond just wearing the right gear, proper training is equally important. You need to be trained in biosafety procedures to understand how to handle biological materials safely. Waste handling training is vital too, so you know how to dispose of materials properly without risking contamination or exposure. And of course, emergency response training prepares you to act quickly and effectively if something goes wrong, minimizing risks and ensuring safety for everyone. Remember, safety isn't just about following rules. It's about creating a safe working environment for yourself and your colleagues. These practices are all interconnected and support the overall goal of maintaining a safe, efficient lab. Let's take a closer look at documentation and records. Maintaining thorough records is absolutely essential in our industry. For example, autoclave logbooks help us track sterilization cycles and ensure everything is properly sterilized. BI and CI results are critical for monitoring bioburden and cleanliness levels. Waste disposal records show that we're managing waste safely and in compliance with regulations. Deviations and CAPA records document any issues that arise and the corrective actions taken to address them. And lastly, training records verify that staff are properly trained and qualified for their roles. All of these records are not just busy work. They are critical for audits and inspections. They demonstrate that we follow proper protocols, maintain quality, and operate transparently. Keeping these records up to date and organized helps us ensure compliance and continuous improvement. So always remember, thorough documentation isn't just about meeting requirements. It's about safeguarding quality and trust in everything we do. Let's take a moment to look at some key references that guide our contamination control practices. First, we have USB 1117, which outlines microbiology best practices essential for ensuring the safety and integrity of our products. Next is the EU GMP Annex 1, a crucial document that details contamination control strategies specifically for sterile manufacturing environments. Moving on, WHO TRS 961 and 1010 focus on biosafety and waste management, emphasizing safe handling and disposal of biomedical waste to protect both personnel and the environment. ISO 14698 is another important standard that provides guidance on biocontamination control, helping us maintain a clean and controlled environment. Lastly, in the context of India, the biomedical waste management rules set legal requirements for proper waste segregation, handling, and disposal. Connecting all these references, they form a comprehensive framework that underpins our contamination control strategies, ensuring quality, safety, and compliance throughout our operations. So, to wrap things up, proper decontamination is absolutely critical if we want to stay compliant with GMP standards. It's not just a best practice, it's a requirement to ensure safety and quality. Autoclaving, in particular, remains the gold standard for sterilization because of its proven effectiveness and reliability. When it comes to disposal, we have to remember that it must be validated to confirm that the process consistently achieves the desired level of decontamination. It also needs to be well documented, so we have a clear record of what was done and when. And, of course, disposal methods should be environmentally safe, minimizing impact and adhering to regulations. All these points come together to ensure biosafety, maintain product quality, and meet regulatory compliance. If we follow these principles diligently, we protect not only the integrity of our products, but also the safety of everyone involved. That's the ultimate goal of our decontamination efforts. For further support, please don't hesitate to reach out to us. We're here to help with any questions or additional information you might need. Feel free to contact us through the provided channels. And with that, I want to sincerely thank you all for your time and attention today. Your engagement is truly appreciated, and I hope you found this presentation valuable. Remember, we're committed to supporting your success beyond this session. So, thank you once again, and I look forward to staying connected.